when Ken presents a text, a presentation, which he is already doing, actually, you can, by clicking view options, you can split the screen in such a way that you can see the speaker at the same time. All right. Um, Now, I think gradually we should start up. I want to add, if I may, Ken, one element to your bio, namely, um, you have also been since, I think, March, a member of the task force of UCSB on COVID. So you have been taking care of the well-being of UCSB people already for quite some time, and maybe your talk is part of that, um, taking care of UCSB members. So, um, what do you think, Brett? Shall we start by now?
Yep, it's a good time.
So, Ken, thanks very much for opening our series and opening it with this formidable subject, theme, um, well, let's say timely theme. Um, Cordial thanks to you. May I, on behalf of all of you on the screen now and participating, welcome Ken Kosik and offer an applause.
Well, thank you very much, Jen. Really, it's a pleasure to speak to this audience because this is a new experience for me, and I really very much relish the opportunity to talk to your group. And this is a topic that is compelling for all of us right now, the COVID-19. What to do with limited knowledge. As Jan and I were talking in advance, I think we have to do sort of outline what we know and what we don't. And that's what I want to talk about today. So in trying to, there I go. So as Jan mentioned, I was asked by the Chancellor to join the UCSB COVID-19 response working group back on March 9th. We were asked to report at 8 a.m. To a building I was completely unaware of. I had no idea that such a building even existed, called Environmental Health and Safety, but found my way over there that morning and met with a team of people, many of whom I also did not know were here at the university, people on the administrative side, emergency operations people, groups that are keeping our university operating, and are, for faculty like myself, are often somewhat invisible to us, but play an important role. So I would be the first to confess that my background is as a neuroscientist. I am not an expert in this area, but it's been the case that for many of us, not just on our campus, but many campuses, we've had to pivot in our interests and our work to address this crisis, because a lot of people and a lot of different expertise was needed, and people were not always available at the drop of a hat. So we've really been repurposing a lot of different people around the campus to contribute to this this effort. And so we reported, and at this time on March 9th, we were still, there was no sort of, there wasn't very much social distancing or mask wearing. We sat around this room and just talked about what to do, because it was clear that this crisis was getting closer. There were no cases yet at that time in Santa Barbara or on our campus, but we wanted to go into action. So what I'd like to talk about is divide the talk into two parts. One is the science, which falls into these categories, what we're going to do about treatment, I'll get to that, prevention, things like vaccines, but really spend a bit of time on what we're doing right now, which is mainly the mitigation and the containment, which I'll talk about. We have to know how to handle both of those. Mitigating is how to limit the spread, and containment is what we do when there are infected individuals and or people suspected of having infections, and how we contain those individuals.
Ken, if I may, just a little practical point.
Yes.
Your video is not on, so we cannot, those of you who can see two screens or a split view, we cannot see your face. There you are. Goody. Merci.
Right. So we'll talk about the science, but as you see, all of those topics are bracketed by this problem, which I'm going to call the backstory. It involves making decisions before we have complete answers. And we don't have complete answers on any of these topics. So decisions are difficult and can be controversial. So so let me just here and see what I can, okay. So let me mention a few things about what we have learned so far. And those are just listed here. We know now that the SARS-CoV-2, this virus is not just a respiratory virus. It doesn't just affect the lungs and breathing. It can affect the central nervous system. The most common symptom, in fact, especially in our student population, the most common presenting symptom has been loss of smell, actually. And we still don't understand exactly why that is, but there's no doubt it's part of this syndrome. And if you're worried about whether you may have the flu or COVID, if you have loss of smell along with your respiratory symptoms, it's much more likely to be COVID. There are other symptoms too that affect the heart, the liver, the GI tract. That is, there's often diarrhea can be associated with the disease. There's many other systems that are affected, and it makes it a very complicated disease. We don't know if all these systems being affected are due to the fact that the virus is directly infecting those cells, or if they're secondarily involved because the immune system is fighting the virus, but it's also attacking some of our normal cells. The other thing we know now is that this virus can be transmitted through the air. It's done so in two ways. One of them is with droplets. Those are little liquid particles. They're heavy. They fall to the ground very, very quickly, and they will are the main reason. They're the main reason we wear the masks we do, because they tend not to travel more than 6 feet, and and they can be blocked by the presence of a mask. So they're in these liquid droplets that are a little bit easier to handle than the other manner in which the viruses travel, which is that when the droplets dry out, you're left with the naked virus behind. It's no longer in any sort of liquid environment. So now it's much smaller. It can travel through the air. It can stay airborne for long periods of time. As I say, these are much smaller. And the masks that we customarily use are a bit less effective for these. I think you're aware of these N95 masks, so that in places where there may be a high concentration of virus, like in a hospital, the hospital staff usually wear the N95s. That mode of transmission, we believe, is much more common if you're in a room with a lot of people that is poorly ventilated. And as long as we follow the guidelines that we'll talk about, and many of you already know, the aerosol transmission will only be a problem when we're in these indoor settings with a lot of people. You see the word fomites down there. What that means is that the virus traveling on surfaces, that is, is it on your groceries, on your grocery bags? Is it in your mail, on your mailbox? there were some studies early on about how if you put virus in a laboratory down on a surface on metal or paper, it can last for quite a while there. But we really have very little data about how frequently that is actually a serious mode of transmission. We just don't know. So there's a lot to learn. And the third big item that we have learned about this disease is, and this is huge, asymptomatic transmission. Many people, especially younger people, will have the virus, can transmit the virus. They have large viral loads, and yet they're completely asymptomatic. So we have to think about how we will handle that problem, and that really is how we get around to the question of testing. And I'm going to talk about testing in a moment, but I want to give a little more background information about the virus. This virus has been identified here. Viruses are they sort of are they're very strange entities. They're in some sort of space between life and organic chemistry. They cannot live on their own. They have to live within a host of some sort, a cell, an animal cell, a plant cell, a human cell. So whether they live in that boundary between life and a chemical world. And when you look at the virus by very high power, you can see here that it has this membrane around it, and it has all those projections sticking out. You see those orange and purple things sticking out, and those are called spikes. And in fact, they're made up of a protein called the spike protein. They are those spikes are what recognize receptors in your nose and in your lungs, often deep in your lungs. They recognize a receptor. It's called the ACE receptor. And once the receptor attaches to the virus, it then gets taken into the cell and starts to do some damage. So a lot of what we'll talk about has to do with this spike protein there, because that's the dangerous part of this virus. You can see how small viruses are. You can see that in the additional pictures that are on your screen here. Very small, smaller than bacteria. Okay, so zoonotic reservoirs. We know where this class of viruses, these coronaviruses, come from, particularly this one. It's probably came from bats, although there is some data that it passed through another creature called a pangolin. This probably happened somewhere in China. I'll talk later about a lot of different pandemics around the world. Pandemics have indeed started in many places in the world, including the US. This one does seem to have come from these creatures in the wild in China, and they live in these organisms. They don't do damage in these organisms to bats or pangolins. They're just they're safe for these animals, but they will replicate and gradually mutate. And the dangerous part is when they jump to humans, and the form that jumps becomes deadly, as what we're now experiencing. So one of the things that we do right away, as soon as we can isolate a virus, is to what we call crack the viral code, that is to sequence it. And that happened very, very quickly in this case of SARS-CoV-2. I'm just showing you here what reams of sequence look like. There's been revolutions in sequencing techniques now. We can sequence very, very rapidly humans, viruses. For those viewers who are knowledgeable of molecular biology, you'll know right away that this sequence here, made up of ATGCs, is not from the COVID virus. It's just a picture that I pulled off the web. You would know that because now this is just a highly technical point for a few people in the audience, but the fact that there are these T's in here means that this is from DNA, and this virus is made up of RNA. So they would have U's there instead of a T. I just make that as a parenthetical point for the scientists in the audience. So this virus is made up of 30,000 of these letters. That may seem like a lot, but if you compare it to how many are in a human, we have 3 billion of these letters. So it's a relatively small number of nucleotides, but it's a sufficient instruction book for the virus to basically cripple our globe, cripple human activity on our globe. That's why we have to learn more and more about it. So one of the things we learn about it is that we sequence these viruses wherever we see them in different countries and different people. And as I mentioned, there are 30,000 of those letters. Most of them are the same from one to the next, but they're not all the same. A few of them are different from person to person because as the virus replicates, it mutates and it changes some of those letters. And those individual changes that we see are very important. So when by the time the virus moved to Italy from China, it had already undergone quite a few changes. And as it came into the United States, we were able to see that many of the cases that were on the West Coast actually came from China because it had a sequence that was more like the one from China, and the ones in New York were a little bit more similar to Italy and probably came from Italy. So what you see in these different colors here are different, what we call clades of the virus. That is how the virus has mutated, and in some group of people within a country, within a community, you can see sequences that are very close to each other, suggesting that those individual groups have viruses that are related to each other and came from each other. And by the way, some of you may ask, you might have heard recently about this question, if you have COVID, can you get it again? And there's now been a couple cases where there's been documented cases of people getting it a second time. How do we know that? Because they sequenced it the first time and it had one sequence. And then after a few months went by, the person got it again and they had a different sequence. It means it's not the same virus, just showing what in medicine we call a recrudescence. It's not a reemergence of the same virus. They got it again. Was a different virus. Now, I mentioned we're going to talk about vaccines. This is going to be very brief, but there are a lot of interesting ideas out there. You know, in the media, you hear about we're waiting for a vaccine. We're waiting for a vaccine, but there's many ways to do a vaccine, and I think the fact that a number of research labs and companies have been involved in doing it is a good thing, because we need to have several approaches. It's the only way this is going to work. We can try to, you see here, over here is the picture, that spike protein here in sort of, let's see, that sort of bluish color and red color is the receptor. And you can see that the virus is sticking into the receptor there. So we can block this interaction in different ways. We can make antibodies to that spike protein. These are highly specific antibodies. That's what most of the companies are doing. That's what your flu vaccines are. They're highly specific antibodies that are targeted to the virus. But we've also talked about, as you see down at the bottom here, of this list of ways to block the infection. You see the use of convalescent serum. You've heard about that. These are people that already have had the infection, and now we take their serum and try to give it to somebody else because they already have antibodies. That's a much less specific way to do it. These are antibodies that people will make that may be useful, but when you're giving antibodies from another person, you're giving loads of different antibodies. They're no longer specific. So it's a little bit of a more tricky way to do it. I'm not going to talk about all these ways, but I do want to, maybe you could look over to the right side of the slide here, where there's a very interesting technique that's being developed at UCSF by Manglik. Here you can see his name and a colleague named Peter Walter, where they want to take antibodies that are to the virus, these very specific ones, but actually deliver them as an aerosol into the lungs directly through one of these nebulizers. And I think that's a very, very clever approach. These are very special antibodies that are much smaller than the usual ones and may be able to get into down at the level of our cells and block entry of the virus. So there's a lot of clever stuff going on, but as you know, we're not there yet. Okay, so now let's change the topic a little bit here and talk about mitigation and containment. These are the only tools we have right now. And I'm going to go through a few of these things. You can see the categories that we are looking at here for how we're going to handle this. Testing. We realized on our campus right away that testing was going to be crucial to making progress, and that we developed a test on the campus here, which is an online publication, is pictured here. We, when this thing first started, a group of us got together, and you see his picture down here in Diego's office with Carolina and Max Wilson, myself, and we talked about building a test that was pretty clear already that testing was not being handled very well by the US government. It was not being handled very well by the state government. It was not being handled very well at all. And it became very, very clear that, and this wasn't clear just to our university, but to many universities that at least had the wherewithal to do it, that we were on our own. We were going to have to sort of develop our own testing. And of course, many universities now have developed their own testing protocols. So we developed one here that is actually based on a technology that you're hearing about a lot in the news today, because this is based on CRISPR. It uses the enzymes of CRISPR. You are aware that 2 women won the Nobel Prize today for the invention of this brilliant technique in which you can strategically go in and at the single nucleotide level, you can make you can change the DNA in any cell. And you do that with an enzyme called Cas9. What was done in this case was to use a slightly different enzyme in the same system called Cas13. You see it there in the title. And this, just as strategically as any CRISPR technique, also goes in and really zeroes in exactly on the virus. But in this case, instead of cutting it like the classical CRISPR-9 does, what this does is it sets up a reaction that generates a signal. So we can, when it attaches to the virus, we can put on another protein that fluoresces, and we can actually see that the test tube lights up if the person is positive. And that's the test that we developed in the lab. Also in the picture here is a postdoc of mine named Jenny Rausch, who was very much involved with that in addition to some other students. And this test is now in front of the FDA for approval. But we're already running it on the campus and have some interesting results, which I'll tell you about. We call the test CREST, which is an acronym for all these words here because it's just so rugged and scalable, very small. But one of the things I wanted to show you here, let's see, there we go. When we were setting it up, I just want to show you a quick text exchange here by one of our people involved, our faculty members here, Max Wilson, in generating this, and sort of show you how science works. There we were sitting around in this office. It was probably 9, 10 at night, and we were looking at the reagents we were going to need. There were some that we were missing. Max sends out a text and a Twitter to the community, and you can see the times here. Here, this was 8 at night. By 10 the next morning, we had answers from several scientists that were willing to help us to send the reagents that we would need to build this test. And because science is truly an international community, and it's the way it works best when there is good communication among scientists who really, generally want to work together. On the other image, you can see here that there is, this is over at the Student Health Center, where once our test actually was built, we were actually able to run it along with the gold standard tests. so that we were able to validate our test. You see in the picture here, Holly Smith, who's a nurse over at the Student Health Center behind plexiglass, in which this was just a trial run. This is James Caesar, who is head of emergency operations on the campus, and one of the doctors of student health in the background there named Ali. And they, so this is a dry run through to see that we had all the procedures in place. And now we've done thousands of tests already. So one of the first findings that we were able to get from this testing was to do surveillance testing. And these were just testing people that were, we said, you know, if you want testing and you're living around here, you are at risk, but we would like to test people and just see if there's any of the virus in the community, because we know there's a lot of asymptomatic cases. So we tested a cohort of a few hundred people, close to 1,000 people over this time period that you see here on the x-axis of this plot. And we got really 0 positives. And then suddenly we tested another cohort, and now we had 8 positives. And so that was a pretty big difference. And it turned out that these positives, these were some of the first positives that were picked up on our campus. These were in asymptomatic individuals. I think almost all of them, if not all of them, were students. And they came to us. They were feeling fine. They just said, hey, I want to be tested. And 8 of them turned out to be positive. So we really caught here the leading edge of an outbreak, and we're able to suppress it by asking these people to quarantine for a little while. And while this was happening in the background, cases in the dotted line on this graph, you can see that cases were in Santa Barbara in the community also going up. So we call it the leading edge on the campus, and we're able to put the brakes on, at least on that part of it. So here's a challenge, because this test, as I say, it's a test that can be what we called point of care testing. You can take this out, you can put it in a backpack and carry it out into the field and do it on individuals. And we went out to we didn't go there, but we talked to some people who are working with various field workers in Santa Maria. And this picture is not Santa Maria, but just wanted to make the point that when we had discussions about taking the test out there, because there was Santa Maria was much more affected than Santa Barbara, and still is to some extent. We wanted to offer the test to some of these people that were out there. And we got a very interesting response. We were told that that probably most of the people working in the fields would not want to take the test because if they turned out to be positive, they would lose their job. So this is a theme I want to come back to a few times here now, because we really have a lot of work to do to figure out some of the aspects, as Jan said, the political aspects of this whole problem of COVID. We also wrote the paper that we published in Spanish, and we could also take this test onto the road more farther afield into Latin America. Social distancing was another kind of mitigation. Look at some of these, you can see how densely packed a school system in China is, but social distancing is hard because we're not accustomed to it. We're social creatures. The economic and social cost is very high, but the efficacy for social distancing is very, very strong. However, we don't have really truly controlled experiments. There's a lot of details about social distancing we don't know. We think 6 feet is the right distance, but a lot of that depends on the setting that we're in. So these are rules that we really do need to adopt to mitigate, but the devil is always in the details. And one of the ways to sort this out is to investigate this number called the reproduction number, or R. I'm sure many of you are familiar with this. This has to do with what's the average number of people that will be infected by any single case. So you can see here, These are other very highly, other dangerous diseases. Ebola, for instance, here, if one person was infected, they would likely infect 2 other people on the average. SARS was more infectious. This would tend to infect 4 other people. And we call these numbers here the R value. One of the most highly contagious diseases is measles. This will affect, one person will affect 9 other individuals. Measles is really just extraordinarily high transmission. And of course, with these, you can see these patterns of going from 2 to 4. These are exponential growth patterns, and that really makes these diseases just take off because of these exponential growth patterns. And that's why you hear this term flatten the curve, flatten the curve. So, so with the number with the COVID, with SARS-CoV-2, we believe that these average R values are probably, so maybe around 2. But it also turns out that the R value may not be the best way to deal with this particular virus. Because we're aware that there are also super spreader events. And this is where one person is infecting a large number of people. And so now we have another number called the K value, or dispersion. This is a kind of number where we would say that maybe 10% of people are responsible for 80% of the cases. That's another way of looking at the statistics. And we know that there were super spreader events that happened in Guayaquil, where they were so overwhelmed, there were bodies left on the street. Same thing happened in Bergamo, Italy, where whole towns were devastated. We know there are also super spreader events as well. There have been some in meatpacking industry. There's been others on cruise ships, nursing homes, ski resorts, churches, restaurants, hospitals, prisons, and I think we're going to have to say that the White House is having a super spreader event. So how can we think about these? These really are a little different than just getting at the R value. We really have to figure out, where these cases come from, the individuals, and then try to contain them in a somewhat different way. Let's talk about contact tracing. Contact tracing is really a tricky matter here because it really involves a lot of what people worry about, an invasion of privacy. These has to do with putting apps on your phone where 2 people would meet, they exchange a key. One person finds out that he or she is positive, and then through a text message, the person with whom there was some contact gets informed. Now, everybody is aware there are lots of potential problems with that you can either, in some of these programs, you opt in if you want to. A lot of this can be volunteer. There's ways to try to make it more palatable. But any way you cut it, there's going to be privacy issues. So when you have societies that are more collectivist, like in Singapore and South Korea, contact tracing has been more successful. In Taiwan, when you do contact tracing and someone has the disease and you ask them how many contacts they have had, the averages, they'll tell you 15 people. In Spain and France, that number is about 3. In New York, it's about 1.1. We're just, on our campus, we're finding closer to 1.1. They're not, people just don't want to reveal their contacts. So now I'm going to change because I think we learn a lot from the historical perspective on these plagues and pandemics. So I'm going to now spend a few moments here in putting the story in some sort of a historical perspective. That's important because what has struck me about this, when you start to read about the history of plagues, and is that the same problems show up over and over again, and there are lessons that need to be learned that even today we haven't learned. That plagues seem to be worsened by human behavior. and their own, and that a lot, and a lot of the damage of plagues comes from the human behavior that's secondary to the virus itself. And really, this concept really began with this plague in Athens. Even to this day, no one's really sure what the particular cause of that plague was. It clearly was an infectious plague. Its description was, the description of the plague was described in some detail in Thucydides, but we really can't pin it down. It's a lot of speculation, but there's no clear-cut answer. However, the plague in Athens, at the time, one of the leaders in Athens was Pericles, who was a brilliant orator, is often credited for what we think about, one of the reasons why we think about Athens as a birthplace of democracy, was responsible for a lot of the architecture that we still look at today in Athens. Clearly a charismatic and an individual who contributed a lot. He died of the plague, and the society became weak. They were invaded by the Spartans. I'm sure you're aware of the wars that went on, and the bottom line is that for a number of years after this plague, democracy in Athens was destroyed, not to return for another 25, 30 years, maybe longer. And it's a fascinating history to read about. So one of the things that you could ask, and I sort of asked this in a provocative way, because I think people are asking it now. Then when we see the success of treating COVID in some countries, is democracy really the best system for handling pandemics? And I'm going to try to address that in a little bit more detail, because I think it is, but we have to qualify that a little bit. Okay, but there are a lot more lessons from the plagues of history, a lot of them that we could really learn from today. You're aware of what was a plague, a bacteria called Yersinia pestis that infected what was called the Black Death in the Middle Ages. There was this plague occurred repeatedly over many, many years. You can see here from 1346 to 1353, it came back and came back and came back. It changed. It literally changed society. There were many ideas about why this was happening at that time. One of the leading ideas that this was some sort of a divine punishment that was being inflicted on people. There were people that walked around from town to town that were called the flagellants, because they would whip themselves and in asking for forgiveness to try to remediate the plague. Another plague that with just hugely serious consequences was this after the Spanish invasion of the Americas. Many diseases were struck the indigenous people, as well as the Spanish, and as well as many of the people that were imported as slaves from Africa. This was an admixture in those countries at the time. But the indigenous people were hit particularly hard. It's said that upwards of 90% of them were lost, or died. So this was a serious problem caused by many different diseases. However, smallpox was one of the big ones. There was a yellow fever epidemic in Philadelphia in 1793. I'm just pointing out a few of these because I think we have something to learn from each of them. This one was interesting because it was also very deadly. A lot of people died. Yellow fever is transmitted by mosquitoes. Of course, no one knew the cause, but the mistaken idea was out there that that people of African origin were immune to yellow fever, and they were then brought to care for people that had the disease, and I'm sure that just caused even more disease among people of African origin, because it did spread to them. And we see that today with the incredible social inequities in the way the COVID-19 is affecting different groups. The Russian plague is another one I just wanted to pick out. Again, these are just a little bit of cherry picking of plagues. But this one was interesting because here in this case, there was an archbishop named Ambrosius who told people that they should not congregate for worship, that people coming together was the way this was spreading. And the people were so outraged that they could not congregate in their churches that they murdered the archbishop and had these terrible riots. I want to mention another flu pandemic of 1889, which was truly a pandemic. Now this was the flu, just like we have influenza today. And it affected a very large number of people around the world. It killed about 1 million people. But my point here is that at this time, 1889, there's no air travel. There's not that much travel going on, and yet, in a very relatively short time, over half a year or a year, this flu killed about 1 million people around the world. The infectivity and the spread of these diseases is remarkable. We have a lot to learn about how that happens. And then last one I want to mention are 6, there's actually probably 7 if you count one in the modern era, but there are 6 major cholera epidemics that I want to say a word about, because at this point is where modern science arrives. And here we have here that, for a long time it was believed that cholera, which had been around for, as I say, there's all these epidemics going on. In this one, in all these cases, the cause was believed to be what was called foul air, or a miasma. And then, and finally, we get the first sort of modern science coming along, where in 1854, John Snow was able to look at a pump in London that was being used by people that were marked by dots on a map of this area over on the right. And it turned out that all these dots are where they're all closest. What all the people who live at those sites have in common is that they visited this pump to get their water. And he said, this pump is responsible. There was a large meeting of 21 governments that said that's not true. His ideas were unanimously rejected, but they changed the handle on the pump, and the cases went down dramatically. It was around the same time. This was an epidemiologic approach. It was around the same time that Filippo Passini actually observed under a microscope in post-mortem material the first cholera bacterium, which he saw this comma-shaped bacteria and said that was the responsible organism. And bringing things a little closer to the present, let's talk about the Great Influenza of 1918 to 1920. This is one that you might be more familiar with. This is one that's thought, none of us know for sure, but it's thought to have begun in the US, in Kansas, at a camp, military camp. Remember, World War I is going on, and this disease spread throughout the world, affecting 500 million people. 1/5 of those died. Truly a deadly, deadly illness. But because of the war going on and all the soldiers, many individuals were tightly packed together in their in training camps and military bases, and on naval ships. Entire ships would return to a port in which almost every sailor was dead. This young people were affected mainly, and it was one of the most deadly viruses that's ever been seen or known about. There are many uncanny parallels to the present. One of the leaders at the time in charge of the shipyard said the so-called Spanish influenza, and by the way, The Spanish influenza, quote unquote, has nothing to do with Spain. It actually began in Kansas. It took on that name for, again, as Jen would say, for political reasons. And but this colonel said the so-called Spanish influenza is nothing more or less than old-fashioned grip, like flu. We recently heard a person talk like that. Conspiracy theories. German agents from submarines brought the influenza to the US. A physician in Des Moines said, I have no doubt that many persons have contracted the disease through fear. Fear is the first thing to be overcome, the first step in conquering this epidemic. Even at that time, there were people that proposed to treat this flu with quinine, which is related to treat malaria, which is very closely related to hydroxychloroquine.
Ken,
yes.
Just how about we take another, you take another 10 minutes or so and round off?
Yeah, sure. I thank you for leading me to be conscious of the time. If you give me 10 minutes or even less, if you want, I can, not go a little faster. So would 10 minutes be okay for the group? Yeah, Jen, you're okay? Okay, I'll assume that's
fine, Ken.
Good. Okay, so I just want to point out here that there's so many misleading ideas out there. It's, look at the advice that was given by the Surgeon General. I'll point out one of these items here. Remember the 3 C's: clean mouth, clean skin, clean clothes. And again, in 1918, it was published that masks are going to be helpful. And it was a very good study in JAMA that we wear masks and increase the space between individuals. It was actually studied quite scientifically, in which people looked at the distance in which the infection would spread. This is before even, in 1918, they didn't know that it was a virus even, but they could actually look through spread in Petri dishes. So where we have the same thing today, maybe if you saw this thing, the Trader Joe's mask meltdown, this woman refused to wear a mask. She said that she could not wear a mask for medical reasons. Well, medical exemptions from wearing a mask. There are 3 medical exemptions, if you exclude Van Gogh's problem. One of them is being under the age of 2. The other is requiring supplemental oxygen, and which she didn't have, and the other is if you're in coma. But so mask wearing can reduce transmission, and one of the ideas out there is that, that again, this can be viewed as an intrusion of privacy, but if cameras were set up in a community in which you were not identifying people, but just identifying how about the mask usage, we could actually see how if compute this R value, the spread, by having some sort of real-time value of R, by knowing how protected the community is. And if few people are wearing a mask, then we've got to turn some dials. Otherwise, or maybe we know things are under better control. So here's some myths that I just reviewed. I'm going to skip that and now wind down here and talk about what's the exit strategy. Well, the exit strategy is clearly science, but what happens while we're waiting? We can think about a vaccine, but there's lots of things to think about, not just how to build it, but is it going to work? To what extent will it work? And will people take it? There's lots of speculations and hypotheses. We can criticize science for how slow it's going. Many people will also engage in conspiracy theories. And because this is a good time to do that, since we don't have the answers. Much of what affects our lives we cannot see, including viruses. And they're only accessible with scientific instrumentation. So we have to take the word of scientists that these things exist. But what it also does is it sort of opens the doors to our imagination, try to fill up that space, and requires a trust in science. And this is where, once we have words like imagination and things like that, this is where, as a neuroscientist, I start to get more comfortable with my own field and think about how imagination works, the enormous amount of space in the brain. This is pictures of brain activation, imaging the brain and showing regions that are activated when we try to remember something or when we imagine the future. Look at all that brain tissue that's turning on as we're imagining the past or thinking about the future. There's a lot of brain tissue devoted to that has to be filled up by trying to fill in missing information. And of course, the numerous creation myths out there are out there. This is one of them from the Hopi Indians, the Spider Woman. But there's thousands of them because humans need to fill in missing information. There's lots of mental space to fill in, and it often gets filled in with conspiracy theories when we're facing the unknown. Social media and religion are very good at filling mental space. I sometimes think that science is less good at filling in that kind of space because it requires that that people have to sort of get comfortable with things like the detailed atomic structure of a spike protein. I mean, that's just not the kind of thing that's going to capture imagination the way a creation myth does. We have to understand how to deal with risk because risk is what this is all about. You make a decision. You're going to wear your mask and you're going to go to the grocery store. You know you're putting yourself at some risk and you have to weigh it, or you're going to have your groceries delivered. And risk assessment is all about making predictions. Am I going to get infected or not with missing information? So this is, making predictions is the most important job of the brain. That's what the brain does. We build our predictions based on our memory. That memory is not really about the past, it's about the future. And we use our memory to help improve our risk prediction. And that's what that's one way in which we can begin to use, I think, neuroscience to help us to understand how to deal with these situations. So I'm going to conclude here with 2 slides, what to do while waiting for an eradication. Well, we have these critical knobs to turn. Isolation is one of them. We can say how much isolation is needed, how much social distancing is needed. Every single one of these has pros and cons, how much testing is needed. I've talked about all of this. We talk a lot on the campus now about whether testing should be mandatory, random, frequency of testing. These are all questions that we don't have clear answers for. Some people even say we should try to go after herd immunity, which means getting the people that are have the disease up to a level where it's now people are no longer, there's not many people that are in, that most people have protection from antibodies, and we're a long way from achieving that. So to adopt these kinds of eradication measures, we have to maybe adopt what the Emil Durkheim, the founder who first established sociology, called social facts. These are things where we have to have a certain amount of coercion over individuals. All of us, including myself, we all are very much attached to the freedom that we all have. But social facts may be a few facts where, for social reasons, we have to have some degree of coercion, and we have to be very careful about what they are because it's a slippery slope. So my last slide here is to achieve that, we want to build a comprehensive scientific enterprise. We need public trust. We need an understanding of the scientific method, a role for the humanities, very important. Social justice, diversity, education, dissemination of knowledge, because science is the sine qua non. We're not going to go anywhere without science. But science alone is an insufficient solution. And I'll then conclude here with this quote from Pericles again, who was lauded by Thucydides by saying, Pericles had the ability to respect the liberty of the people and at the same time hold them in check. Thank you all very much.
Ken, thank you so much. What a wonderful talk and overview. And please, can we ask everyone, now is question and answer time. You can post a question on the chat to form to speak. I think it would be friendly if you can activate your video so we are visible, so we have a sense of community and sharing. And please, the floor is open for questions. Let me just start with a general point. Um, the staggering variety in responses that we find all over the world in relation to COVID. Say, I'm talking to a friend in Kigali, Rwanda, who tells me everywhere you go now, you go to a supermarket, you go to your office or a department, somebody will ask you right away, where is your hand sanitizer? And put on the hand sanitizer now immediately, so we can see it. There is an active engagement and in surveillance. And here is a Central African country, very active, very engaged, in staggering contrast to a place like the United States, supposedly advanced country, where 8 months after the virus awareness started, still every night on television and other media, we must talk about basics. Yes, masks matter. How do you account for this wild variety in governance, in social organization, besides the varieties in imagination? What is your response to this striking difference?
Well, we like to think of our country as a melting pot, but really it's more like a vegetable stew where there are all these groups with their individual identities, and that's very important. We don't want to lose that. But what happens, of course, is that that degree of independence, which is so important, also gives rise to just a numerous opinions. I mean, I'm not saying anything deep right now. It's pretty obvious when you have a society like Korea or Taiwan. There's much more unanimity there in everything from how you behave to how you cut your hair, and it's just we don't have a system like that. And I think that's what we really have to think deeply about. I don't have an answer for your question, but I think we know what we have to think about.
Thanks, Ken. Peter Bloom. Peter, would you raise a question, please?
Yeah, I actually tried typing it in on the chat.
Yeah, I saw it.
But it's so interesting in the 19th century with the Pasteurian Revolution related to the demonstrations with sort of new kinds of optical technologies really transformed the way people understood various kinds of infectious diseases. And what I'm wondering about with COVID is the extent to which, on the one hand, we think about media in this context of how we're understanding COVID in relationship to media. There are all kinds of approaches, but I'm just wondering, as a representational way of thinking about it. But from the scientific perspective, I'm wondering the extent to which new techniques of visualization are transforming the way we understand the disease and how this has impacted modeling techniques that you've been involved with.
Yeah, that's a great point. I think one type of modeling that I've seen that I'm sure has influenced some people is where you have some people sitting around a table and one of them has a little bit of dust, and about 20 minutes later you see that dust is touching everybody's face and hands and is all over the place. We just don't appreciate, due to the invisibility of the virus, how how distantly and how easily there is spread for all of this. And I think the visualization techniques of that we have available to show that kind of behavior has been actually quite helpful, and maybe has affected behavior to some extent.
Yeah, I mean, if I could just follow up for a second, what's so interesting with Pasteur was the connection with, microcinematography in particular. And, that had a very big impact on thinking about movement related to early media, being able to capture movement. And it's so interesting with all kinds of medical techniques these days, the invasiveness of it, the microscopy associated with it allows us to see things that we can't. But then one of the barriers seems to be operationalizing how we consider treatment, just as you were talking about different kinds of approaches to, how do you deal with COVID and the different methods, which is really about interaction. So can you see interactions as opposed to being required to test it? Is kind of the idea of the optical nature of what happens visible, or does it just always have to be measured in terms of what happens to patients? And what's the relationship between those two different kinds of strands?
Yeah, I mean, that is truly an important research question. It's a great question. And the reason we have these sort of measures that that are quite unsatisfactory, social distancing and mask, is because a lot of the questions you're asking, such as if we can actually see what's happening, we would be able to really, I think, change a lot of the way we're handling it. Let me give you an example. We don't really know what is the viral load that will cause an infection in an individual. How many copies of the virus do you have to actually inhale or come in contact with? So, and then someone who is shedding virus, how many are they shedding? We have no real serious quantification here of the problem. And that's why these measures are so soft. We're doing the best we can. We're turning these like social knobs the best we can. But it's not being done in a strictly scientific manner in which it would be done in a laboratory. We don't know how, but it's what we need.
Please, the floor is open, friends, colleagues. I would slip in the point then. I'm in conversation with a colleague in Cuba, in Havana, and he calls Cuban approach to COVID, in Cuban style, he calls it dancing with COVID. And generally, there is a distinction between two approaches: the hammer, shutdown, lockdown, and the dance, whereby you have a much more calibrated and refined approach. They use this also in Denmark in schools, whereby they let in cohorts of pupils at different times in different ways to avoid the total lockdown, but let in smaller groups. So there is a great variety in approaches, and here in this country, it seems that only a narrow spectrum is being talked about.
Yeah, it's a beautiful metaphor. I think it again relates to how we turn these knobs. And there are ideas out there. There are ideas like pods in which people who have all been tested and have some commonality among them can actually engage in as much maskless social interaction as they want, because they trust each other and they've been tested and they're all negative, and that they can be made up of 8 people, 10 people or more. So there's lots of ways in which we're trying to circumvent this problem until we get something that really can knock it out completely.
Sadaf, may I invite you to unmute and raise a question?
Yeah, absolutely. So I was just wondering, I think there's just been a lot of like politics involved surrounding this topic, specifically about how the US is dealing with the situation compared to other countries. Does the US's population factor into our current dilemma in terms of like, you're looking at the Netherlands, you're looking at Denmark, these, Swedish countries, or like these, Sweden, should I say, or like these Nordic countries, and they're doing so much better, and we're clearly not. I'm just wondering, like, is that a factor as opposed to like just kind of, the lack of policies and the fact that Trump is, playing it down?
It's such a multifactorial problem, and I have no doubt that you're right that population is a factor. But China has a big population, and they have used a strong coercive political system to pretty much I don't want to say eradicate it, but they have really a place like Wuhan, where it was really bad, as you know, is now essentially free of disease. So we really, we just have to make these decisions around the trade-off of how much coercion we will accept, and how much risk we're going to accept. It's very difficult. Even during the 1918 pandemic, it was quite remarkable when you look at the variation of disease from city to city and town to town across the United States. There were towns in Colorado which almost the entire population died, and there was another town where they just didn't let anybody in or out, and they all survived. These solutions rub us the wrong way, but so we have to figure out. I like what Jan said about the dance, and I think we really we have some work to do.
I saw a question by Sabra. I see it on the chat. Sabra, do you want to raise that question? Do you want to share it?
Yeah, sure. I mean, this is kind of working off what Sadif also asked. I just want to say I'm not a scientist. I'm a cultural anthropologist, so I can't talk any of the science of you. But part of your talk, you talked about the imagination and about how limited knowledge has affected like public response. We need to be, kind of like responsible as people, not just as like scientists. Hold on, I want to start the video.
All right.
Hold on. Yeah, okay.
Yes.
Where was I? Oh, so do you think that the lack of the control or the lack of a control because of this like limited knowledge may be playing on the responses where people refuse to wear masks or they refuse to abide by the social distancing, and they have very aggressive responses to this? Do you think that may be part of like grabbing control on something that just seems completely out of control, either because our government hasn't put, like policies into effect that we feel help us, or, just the way our leader has been treating this kind of like a game, or just not, I mean, you know what I mean?
Yeah. Well, the woman who had the mask meltdown in Trader Joe's, she said that she was obviously cornered, and she tried to give a scientific reason, a medical reason for why she wasn't going to wear a mask. Obviously, she was lying. That is not the case. There's no one that could shout and scream like that, and and still have she was obviously not hypoxic. She didn't have low oxygen. There was no doubt about it. She had no excuse for not wearing a mask, and she felt cornered because she was being challenged, and she made. And she didn't give her honest opinion. She said that there was a medical reason, but her honest opinion was, and you can see this in a lot of the, if you look at the chats that followed up on that, and online, and all the Twitter stuff that happened, the real view is that that she feels that she doesn't want someone to come in and tell her to wear a mask, She doesn't want someone to come in and tell her not to smoke. She doesn't want someone to come in and tell her to wear a seatbelt. She doesn't want someone to come in and tell her that she has to stay inside and she can't go outside. And, and so those things, they start, so far, we say, okay, where are you coming from? You don't even want to wear a seatbelt? My God. And then you tell people, well, you can't go out and go to your job. Well, and then they say, well, my kids are going to starve. And so, there are these boundaries where coercion only works so far. And I think the mask lady in Trader Joe's, drew this boundary at a point which most of us would think is completely unreasonable. There's that some social coercion is how we run a sane society. But if someone sees that is already over the line, we have to figure out how to be rational with people like that. Or I don't know if we can be rational, but how to be, in some way handle those kinds of opinions.
Ken, if I just might react to this kind of point, floor is open, of course. Earlier, you mentioned the difference, say, United States, Korea, or Taiwan, where on the Korea-Taiwan side, there is more social group cooperation. And on the American side, there is more individualism. How about this, that instead of this kind of binary type of distinction, we recognize that also in this country, there is a lot of group think and there is a lot of authoritarianism in which the dear leader is also in charge of many rabbit holes that are reinforced, social media and so on and so forth. So that there is a lot of group and collective behavior here. It is just organized on different premises and different principles than the group behavior in Japan or Korea, where masking culture is very ordinary. So there are two forms. There are both group behavior, but they are just on different premises.
Yeah. So I would say that the collectivism of societies like that is certainly a factor, but it's not the only factor that makes the distinction. In those societies, for better or worse, I don't know if it's a good thing or a bad thing, but there is greater trust in the government. So that when someone in Taiwan says that they have 15 contacts, it turns out that one of those contacts might have been a person who was having an extramarital affair or was working a secret job that was illegal. But they revealed it because they had confidence, the trust, that revealing these people was not going to bounce back and hit them. We don't have that trust. The other thing that we don't have that a lot of those countries have is we don't have a safety net for people. We can tell them to quarantine, but then what? We tell them they still have to pay their rent or they're going to get evicted. We have no social safety net here. And there is a little bit more of a social safety net. So I think the collectivism is certainly an important factor, but it's not the only factor.
Yeah, social cohesion variables also matter. Please, friends, colleagues, do you want to come in with, please, Anshu? Wait, yeah.
Can you hear me now?
Yeah.
Yes.
Yeah, okay, great. So thank you very much for that talk. It was really, really informative and so well organized. And I really appreciate your point about, bringing in the human behavior, which actually affects people in different ways because, the way the society is in fact reacting to things and the leadership. I just wanted to point out that in India, for example, we had a lockdown where people had to organize themselves in 4 hours, and the lockdown itself created such misery, and because that was a reaction of panic in some senses by this very powerful person who's at the helm. The question I was bringing in is that the media has been extremely partisan in the United States and in many other places, including India. And how does that play in? Because there's so much polarization that you find in society today that two sides are not talking to each other in some sense. You're polarized and you believe in what you believe. So if in some ways democracy works when the media works, right? It's doing its job, it's reporting, it's telling you facts as they are in some ways. So this polarization, I think, in my opinion, seems to have affected the way in which we tend to react to even things that seem to be scientifically, quite clear, but we are reacting in a very different way to that. So do you think, the way in which people have been polarized and how media, tends to work towards that polarization, how does that affect the way we react to this?
There's no doubt about the role of media here. I totally agree with what you said. It's I made a little note on my slide there about how social media is filling up our imagination space because we don't know how to explain so many things that are happening, and but the media has no reluctance about filling in our imaginations. They will do it in ways that to which we're susceptible, and that will lead us to buy their products, believe their rants, whatever it is, whatever agenda they have. There's something out there to there's people there that want to take advantage of it. The media also, I just like the media has a way also of stirring us up into a lather that is just like I saw like recently there was some headline in CNN that said Biden uses a prompter. Breaking news, as if like it was so serious that he was, he had to rely, you know what I'm trying to say here, that he had to rely on a prompter, there's all this stuff coming along now that they're trying to impugn his mental status, all this kind of stuff. And it was breaking news that he was using a prompter. I'm sure we're all feeling this. You go on and you check what's going on CNN or wherever your outlet is, and what's the feeling that you get? Anger, right? And anxiety. And that's not easy to deal with like multiple times a day. It's just, is that part of what the media should be doing, is like keeping us stirred up and keeping us stirred up in these extremely partisan ways? I think it's important to think about that. But on the other hand, I must say the situation out there is getting very rough, and we have to keep informed too, especially now when the government is just crossing the lines time after time after time.
Is one way of looking at it that this is a time when small government isn't functioning adequately, but big government, such as in Asian countries, also in Nordic countries like Germany, that have social safety nets and adequate and competent and ample healthcare systems, they are able to cope. They also have inspired trust in government over time. But a country where the US and the UK are examples where government agencies have been eroded over time, and all the reliance has been on corporations and big tech and so forth. And in a public health crisis, these are not helping us. Corporations like Amazon, they can get richer and so forth, and Facebook as well, but they're not helping at all. So people here collectively have put all their eggs in the wrong basket.
Well, there is this, I think a lot of what's going on right now in politics, maybe we could have gotten through it more easily if we weren't also struck by a pandemic. I mean, that's a platitude to say that. Everybody knows that. But part of what we need in governments is to prepare for these eventualities. And I think everybody on this call is aware that there was, a pandemic task force in place for a long time and dismantled in the current administration before COVID broke out. People are aware that there are risks out there, and we know there's risks to the environment. We know there's all kinds of risks, and the fact that and pandemics, the emergence of a seriously pathogenic virus, a zoonotic, or coming from an animal reservoir, is a very well recognized risk. It's already happened a lot of times. Ebola, SARS, MERS, we know about it. And this is where, governments, this is where individuals, a small community cannot do what has to be done at a very large scale, which is assess these kinds of risks that we know are in front of us. And those are things, those are topics we really can make a difference.
Elijah, do you have a comment you want to make? You made one on the chat. Entertainment is a form of education.
I do, but unfortunately, I don't really have time. I have class in a couple of minutes. So
all right.
You.
All right. Okay. Ciao, ciao. Please, folks, would you want to come in?
I'd like to ask about confidence in data. We've been, talking about whether collectivist governments and coercive measures might be better equipped to meet this challenge. But specifically, say in China, where there's digital footprints. So I know we have a color code system here in Isla Vista, but there's one, where the apple turned green, yellow, or red. Sometimes a citizen has no idea why. Yet there's confidence in data systems. And moreover, sometimes geolocation, police surveillance, all of this will ensure. So what I'd like to ask is any of this feasible if there were to be a downturn in the way things are, where we could install that for our student or resident population, where people can voluntarily opt in, and then it would be coercive. You would be tracked, if you went to Los Angeles, and then you would have to voluntarily self-quarantine. Because right now the problem with the app every morning is that it's based on self-reporting of symptoms. Everyone will just report, oh, I feel fine. So could there be some geolocation surveillance or more coercive measures there?
Yeah, so that's a very active discussion right now, and I think there will be, people who work in the university in the IT, like Matthew Hall. There's people out there that are doing this, and I think we're going to get a little bit more information about that in the near future. I think you're right. It's probably going to happen because we have to figure out, we now have to start to figure out the winter quarter.
Right. Thank you. Look forward to the results of that discussion.
Yeah.
Thank you.
Vladimir, please.
Yes. Hi, everyone. Ken, thank you very much. It was a fantastic presentation. I'm really glad that you brought up the comparison between the Spanish flu pandemic and the current pandemic. And especially the point that the Spanish flu, it actually originated in Kansas, but then it was named, Spanish flu for political purposes. And we all know how the current US administration has been calling this virus, right? So I find it fascinating that a virus, non-human agency, is being mapped onto a nation state. So my question, which is kind of open-ended, is, do you see some new ways, like previously unseen ways, in which this virus this pandemic or responses to it have been really weaponized for political purposes?
Well, I mean, as you said that was as much a comment as a question, because you know, I think we have to both agree that the evidence is there. You know, we know what the political situation is, and we know that what's the way this virus has been labeled. You know, I can only agree with you, and this is another one of the numerous ways in which we're falling off the rails. Jen, I think things are slowing down here. Why don't we do you want to let people go to their next thing?
Yeah, please. Anybody else? A question or comment? Esther?
I just want to say the whole discussion about sort of dancing with the virus and the whole role of imagination. It reminded me of the ways that the Maroons in anti-racist societies hundreds of years ago used to dance their resistance in order for it not to be registered as war movements. They would do these war movements slowly as if dancing. So I think that Jan's insight is deeply profound in so many ways. And I wanted to thank you for such an amazing presentation. Thank you so much.
Thank you. Thank you very much.
Please, Ken, and everybody, thanks for joining. Ken, thanks very much for this open talk at such a safe distance, Ken. Thank you.
Thank you all. I appreciate your attending. Thank you.
All right. Thanks. And see you later, everybody. Appreciate very much. Bye. Thanks.
Bye.